I suppose it's just as well the Dutch invented gin, really, because it helped to solve one of those little problems that all colonial powers came across, sooner or later, when they were running places like Java. Mosquitoes. Speaking of which, and mosquitoes mean malaria, which might be why the Dutch were also the world's greatest producers of this stuff, quinine, grown, as it happens, here in Bandung. And that's where the gin comes in, because quinine tastes horrible, and less so with a shot of gin, which created another little problem, running a colony drunk. And they all were. The guy who solved the problem for the Dutch and for all the Western colonial empires is a perfect example of what this program's all about. How history is full of people with bright ideas. I don't know if you've ever been to Switzerland and done the tour here in Geneva, but you've got to hand it to the Swiss. It's clinically clean, this place, isn't it? About as far from malarial swamps as you can get. So it's ironic that it was here the quinine problem got solved, thanks to something that people have always done on the tour here, like going to a famous Swiss jeweller's and bankrupting yourself with an expensive present for your significant other. Which is why, in the late 18th century, a fellow here whose first name is Jacob does so well at being a jeweller, he retires to the bar, well, to experiment with carbonated water, which is all the rage at the time, and invents the solution to the foul taste of quinine, because he puts the quinine in sweet fizzy water, like this. And you knew that, because Jacob's second name was this. Schweppes tonic was so successful, there was no stopping it. Literally, because the trouble with effervescence is keeping it in. They tried cork, tar, wire, paper, bits of string, and nothing really worked. Until a fellow in Baltimore, in 1892, came up with something that did the job so well, you don't even notice it when you handle it today. This bright idea, the bottle cap, kept all the health-giving fizz in and taught the modern world some very bad philosophy. Use it and throw it away. One of his employees took the concept a stage further with one of the greatest throwaway bright ideas of all time, and changed the face of history because he changed the face of people. His name was King Camp Gillette, and thanks to the availability of really good steel, his new throwaway razor blade made him a millionaire. The steel, of course, was available thanks to somebody else's bright idea: how to get steel making to take less than forever. Here's the problem. You take a whole day to produce molten iron, which you will then pour into molds and let it cool for hours and hours. Once this cast iron is cold, you stack it with charcoal in a box and keep it incandescent for a week. And the charcoal seeps into the iron and makes a thin layer of steel that you then hammer off. Two things to say about that. High-speed steel it ain't, and the bits of steel that you hammer off are brittle, and there isn't a container around that will take the kind of heat you'd need to remelt it all and fuse the stuff together. And then along comes a clockmaker called Huntsman with the bright idea. This, a special pot made of clay and a top-secret new ingredient. This pot will take amazing heat and not melt down. So you put bits of hammered-off steel in here, heat it to unheard-of temperatures with a new wonder fuel called coke, and in hours you have Huntsman steel that was going to be good enough for the kind of clock springs desperately needed by certain travellers interested in time. Here's why. Time's the problem. A 360-degree Earth turning once every 24 hours means that the sun comes up 1 hour earlier for every 15 degrees you go east, or later if you go the same distance west. So if you know what time it is, then you know how much different sunrise ought to be where you are. This is highly critical for a navigator, because 1 degree is 60 miles, and that's only 4 minutes in terms of time difference. So in 1762, another clockmaker called Harrison comes up with a fantastically accurate new chronometer. Accurate because he solves the problem of the way any metal spring expands or contracts with all the different temperatures you go through when you sail around the world. Here's his little bright idea. Say it gets hot in the tropics and your spring expands, say, that much. So your clock is going to run slow, right? Not now. Harrison puts onto the spring a little metal slider that also expands, exactly the amount to shorten the spring back to where it should be, or do the opposite when it's cold. So now a ship coming home could hit the spot within 500 yards. Fantastic, eh? Not fantastic enough. Because making a pinpoint-accurate landfall was no good if you ended up a pinpoint-accurate shipwreck because the lighthouse had fallen down, which they used to, until a really boring guy called Smeaton tried using dovetailed stone blocks on a lighthouse, and it never fell down again. Smeaton also invented a diving bell, designed harbours, and what else can I say? Oh, in 1770, when Smeaton was in Scotland, he met a man who ran an ironworks and designed a water-powered boring machine for him. Well, I said he was boring. The boring machine bored cylinders for pistons for steam engines and wasn't a patch on the upgrade that followed later. And that's Smeaton. Well, I did say, didn't I, that the story of his life would cure your insomnia. Speaking of which... Meet John Wilkinson, who had his bright ideas while he was asleep. Keep your eye on the ball. Here he is, dreaming of a bright idea, and here he is, waking himself up to do something about it. Ah, well, it takes all sorts. The particular bright idea happening up there is the one he had in 1774 to upgrade the Smeaton borer by rotating solid iron rolls against a steel cutting head and scooping out the center of the roll all the way through to make incredibly precise cylinders. Without which, James Watt's steam engine would not have worked and the entire Industrial Revolution would not have happened. Ah, he's gone back to sleep. Wilkinson was the hottest iron maker there ever was. Built the first iron boat, coined his own money, invented rifling for rifles, made all the iron pipes for the great Paris waterworks, and had himself buried in a cast iron coffin 3 times. Well before which, his greatest scam. In spite of the fact that we Brits are at war with France, Wilkinson manages to smuggle to Napoleon the other thing you can make with a cylinder borer: cannon barrels to fight wars all over Europe with. Now, one of the things war creates is orphans, which Napoleon's war did, here in Stans, Switzerland, where in 1799 a middle-aged ex-farmer set up an orphanage for them and changed the course of education for little kids all over the world. His name was Pestalozzi, and his bright idea was, to say the least, uncomplicated. Lots of music and games and exercise, children teaching children, no memorizing, no classes, no corporal punishment, no textbooks, but above all, no school. This was education for Pestalozzi, taking kids out of school and getting them to learn from direct experience. Geography from maps of your nature walk. Show kids a mountain and then teach them to spell it. Teach science from the way nature worked. Above all, develop the kids' natural abilities to observe the world and make sense of it in their own way. Have their own bright ideas. The guy who turned Pestalozzi's little bright idea into the kind of PhD dissertation material that turns your brain to porridge was a German called Herbart, who got all excited by the idea of Pestalozzi's little kids getting direct experience from life. Herbart reckoned that each new experience was added to the ones you'd already had, and that as each new experience changed your total experience, it changed you, but that you were only aware of the change if something happened to make you aware. Something that caused the event to cross your threshold of consciousness. A concept Herbart invented and proceeded to measure, thus turning psychology into the exact science it is today. Which is why I'm telling you this in the mysterious East. Because a guy who was at college with a friend of Herbart's brother was deeply into Eastern mysticism and went to seances and wrote about the souls of flowers and such like, and was called Fechner, took Herbart's ideas and turned them into what he called psychophysics, which was all about measuring awareness. If experiences, like this dance for instance, changed you like Herbart said, then at what stage in an experience did you notice it happening to you? At what stage did you become conscious of the effect on you? If you know what I mean. If you're still there. So it was Fechner and his college pal who came up with the next bright idea. An amazing new scientific law that I bet you've waited all your life to hear about. The law of the just noticeable difference. And I kid you not, this law would turn out to be of cosmic significance. Once, that is, around 1860, they'd got down to some really heavy research. This kind of heavy. The weightlifter is given more and more heavy weights to lift and asked if he notices. And I'm being perfectly serious. Turns out, whether you notice the difference with the extra weight depends on the weight you started with. And the scale of the difference is always the same. If you double the basic, you have to double the extra. So if for 100 kilograms it was 2, then for 200 kilograms, it's going to have to be 4. Okay, here's one for you. No muscles needed. 50 candles. Add 1. Notice the difference? You should. That's the just noticeable difference in light levels the human eye can detect between 50 and 51 candles. Which, as I said, was to become of cosmic significance. Here we are on the equator. North here, south here. All marked obligingly here in Indonesia by this equatorial monument. Now, I said that just noticeable difference would turn out to be of cosmic significance. Astronomical cosmic. Because here, in the southern hemisphere, is where astronomers have always come to look up at a sky much more full of stars than here in the northern hemisphere. One of these guys, called John Herschel, comes south of the equator in 1834 to look at double stars. At night, of course. And gets into the just noticeable difference business, measuring the brightness of stars. Now, back then, the official brightness of the brightest star in the sky, that is to say, a star of first magnitude, is said to be equal to the light from a plumber's candle at 1 mile distance. Call it that. Okay, now for Herschel's bright idea. What you do is find another star much dimmer than the first. Call it that. Now, you use a lens to bring the dim star close enough to the bright star so that their brightness is exactly equal, like this. The distance you had to move the lens in order to do that is a measure of how dim the dimmer star was. Okay, here is where we get cosmic. Turned out the different levels of stellar magnitude, each magnitude marking the just noticeable difference between one star brightness and another, meant that a star of fifth magnitude was actually 100 times dimmer than a star of first magnitude. And Fechner also worked out a formula to relate brightness to how far away a star was. Okay, now for the sky. This is a star cloud in the southern sky in the Magellanic Clouds, and this is a double star. Remember Herschel? A dim star orbiting a bright one and going bright dim, bright dim. Now, from a distance, that could look like a single star varying. Turns out there are single stars that vary, called Cepheids. And by 1920, they know the faster the Cepheid varies, the brighter it is. An astronomer called Hubble knows brightness relates to distance. So when he finds Cepheids in the star cloud, dim but varying fast, he knows they're a long way away. Now, he knows how far the star cloud is. So he works out the Cepheid distance and knocks everybody's cosmic socks off. Because his Cepheids are sitting out there 100 million light years away. The first sure indication of the incredible size of the universe. So, thanks to gin and tonic and bottle caps, steel knives and clock springs, lighthouses and cannon, teaching kids and weightlifters, we know that, as far as the cosmos is concerned, we haven't remotely reached the end of it yet, unlike this program. Oh, why was I here in Java? Well, this observatory was built to look for double stars, and it was built using money from quinine here in Bandung. Good health.